All right, so on page 3, what we're doing today is first we're going to start out by figuring out whether or not two ratios are in fact proportional. So let's review real quick what I mean by the word ratio, all right? A ratio compares two quantities. So we're going to start, for example, with a 2/5, all right? Now, if I create a proportion with 2/5, I could do something like double both the numerator and the denominator. So if I double the numerator, I get 4. If I double the denominator, I get 10, which means 2/5 is in fact proportional to 4/10. All right? Now what we're going to be looking at is figuring out ways to prove that they are in fact proportional. Now what I'm going to do is I'm going to erase this real quick, and I'm going to ask that we now look back up here. 2 out of 5 is proportional to some number out of 15. So what we're going to do is we're going to take a look at the denominator. What do you have to do to 5 to get 15? Multiply by 3. So if we take the 2 and multiply it by 3 as well, we're going to get a 6. What that means is that 2/5 is proportional to 6/15. Now if I were to ask you whether or not 2/5 is proportional to 8/15, we already know it should be a 6, not an 8. So now let's talk about some ways that we can prove that it's not proportional. If I take the 2/5 and compare it to the 8/15, one thing I can do is cross multiply. If I cross multiply for this, I get a 40. Now when I cross multiply here, I get a 30. And since 30 is not equal to 40, they are not proportional. Okay? Now another thing we could do is we could divide. We could take the 2 and divide it by 5, and we could take the 8 and divide it by 15, and we're going to realize that we do not get the same decimals there. All right? So now I'm going to erase this, and the next thing we're going to take a look at then is whether or not 2/5 is proportional to 12 out of the 30. All right? Now I think we can all agree that the answer is going to be yes. And right here, we're going to talk about the 4 things that you could use as your justification for reasons why, yes, this is proportional. For the first one, a lot of you are getting very good at recognizing that the 5 times the 6 would be a 30. So the first method that a lot of you are getting comfortable with is the scale factor. And you're catching that times 6 gives me 30. So if I do times 6, yep, I get 12, and therefore they are proportional. All right, now let's take a look at the second way we can prove that this is true to reduce. If I take 12 out of 30, if I reduce that, both of these here are divisible by 6. So if I divide by 6 and divide by 6, I'm going to end up with my 2/5. So once again, because it reduces to 2/5, we know that the two fractions are equal. All right. Another thing I could do is to take this 2 and divide it by 5, I'll get 0.4. If I take 12 and divide it by 30 in my calculator, I'm also going to get 0.4. And we know that 0.4 equals 0.4. So once again, anytime your two fractions are equal to each other, you have a proportion. Now the last thing that we can do to verify that 2/5 is proportional to 12 over 30 would be to cross multiply. When we multiply 30 times 2, we get 60. And when I cross multiply 12 by 5, I get 60. So the last thing there, yep, that holds true. Cross products are both 60, which means we do have two proportional ratios. So now what we're going to do, and just so you guys know, the SOL loves questions like this set right here. We're going to select all of the pairs of ratios which are proportional. So all you're looking for then is two fractions which are equal. Now we're just going to work through them from left to right. We're going to work through all of these, and we're going to determine which set of fractions would in fact form a proportion. So with this first one, we've already talked about it. What we want to know is this true? Is that true? So you could use this first thing, this second thing, this third method, or this fourth method. Totally up to you which you want to get good at for proving whether or not it's a proportion. So if I do the first thing, I can check for the scale factor. The scale factor for the denominator is 2, and it is the same scale factor for the numerator. So according to the first check step, yep, we do have a proportion. Now let's take a look at the second check step then, dividing them. If I divide 2 by 5, I get 0.4, and 4/10 is also 0.4. So because they both equal a 0.4, yep, they're proportional. Another thing we could do is to reduce. Oh, sorry, I just mixed those up. I just flip-flopped those, my bad. If I reduce now, I can see here that this reduces to a 2/5. So reducing is another thing you can do to prove. And the final thing would be to cross multiply. And when I cross multiply, we get a 20 and a 20. So, yep, we're going to select that for proportional. So what I'm going to do now is, for the second one, I'm going to push for cross multiplying. If I cross multiply 1 times 8, that's an 8. And if I cross multiply 4 times 3, that's 12. And since 8 does not equal 12, we will not select that one. Just so it's a little bit cleaner, I'm going to erase this now. We did select the first one, and we are not selecting the next one. So now let's take a look at the third option. For this one, instead of cross multiplying, let's just divide. Y'all, what's 12 divided by 2? 6. What's 18 divided by 9? 6. That's true. Proportional. All right, moving right along to the fourth one. If I reduce 15 divided by 3, 15 divided by 3 here is 5. And 1/5 does not equal 5. So no. All right, for the next one, again, it's totally up to you if you want to try to reduce the fractions. In fact, here, if we take a look at them, we notice that they're both already reduced. And since they're both reduced, we know for a fact 1/5 does not equal 5/8. Those two numbers, they're reduced fractions, they don't equal each other. Now, if that's not good enough for you, we can cross multiply. 1 times 8 is 8. 5 times 5 is 25. And since 8 does not equal 25, they are not proportional. So no. Now for the next one, if we reduce, we could take 16 and divide it by 4. And 20 divided by 4, meaning the scale factor is 1/4. And yes, we would select that one. And last but not least, just ask yourself about 3/6. What do you know about 3/6? It's a half. Is 12 half of 18? No. So no, we're not going to pick this one. Now again, in case that's not good enough, you can cross multiply. That's 54. And 12 times 6 is 72. So since they're not the same, no, we would not pick this. So I'm going to erase this now because that got a little messy. Again, when determining which pairs are proportional, you're basically looking for two fractions that are equal. And we selected the first one, the third one, and the next to last one. Now I want you to just pause the video, and I want you to try this next one on your own. And when you hit play, you're going to hear the explanation of me going over it. So go ahead and hit pause. And right now, I just want you to try these on your own. And after you're done, you can hit play and see if you got them right. Okay, so let's see how you did here. For the first one, 7/3 and then 14/6. I easily identify a scale factor of 2. 7 times 2 is 14. 3 times 2 is 6. So yes, this is a true statement, and yes, we would select it. Now for B, if I divide the denominator by 5, meaning I take 1/5 of it, I get 10. Or excuse me, I get 2. 10 divided by 5 is 2. But if I take the 55 and divide it by 5, I should get an 11. So no, B is not going to be proportional. Another way we can prove that, If I take the numerator, 55, and divide it by 10, I'm going to get 5.5. Well, what's 12 divided by 2? 6. So since those are not the same, we are not going to select them as proportional. All right, moving right along here. For C, I don't identify a scale factor, and so what I might recommend doing then is just reducing. 7 is a prime number, and so is 11. So 7/11 is reduced. Now 15 is not prime. We could divide it by 5 or by 3. But 23 is prime. So that means both values are already reduced, and we can very easily see that those two fractions do not equal each other. So since that's the case, we are not going to select that. Now let's take a look for part D. What I would recommend for part D is I would actually just recommend, because you're probably not going to catch that 3/42 can reduce. For D, let's cross multiply and see what we get. 70 times 3 is 210. Now it is okay if you use your calculators today, folks. 42 times 5 is in fact 210. So yes, these are proportional, okay? You don't want to have to worry about reducing 3/42 and 5/70. And so let's see now for the very last one, or sorry, for part E, let's check. I think let's just try the cross multiplying thing again. Let's do 9 times 17, that's 153. And if I multiply 13 times 13, that's 169. So that we don't get the same answer, so we will not select E. And let's take a look at F. Ooh, for F, I see a scale factor. I see times 3 from here to here. And since 9 times 3 is 27, then yes, we will also select that. So to review our answers for this U try, we will select A, we're going to select D, and we're going to select F. Okay? All right. So all we just did in this top part of the notes so far on page 3 was learn how to determine yes or no if two fractions are proportional. If the fractions are equal, it's proportional. If not, nope. All right. So now what we're going to do out here with number 1, 2, scratch that out, 3, and number 4, is we're going to learn and get good at, this is what you guys had to do for homework, we're going to review how to solve for x, and then you're going to see some word problems in a second on pages 5, 6, 7, and 8. So first, let's review what you did for homework. In a question like this, most of you, for your work, would show me that the scale factor is 3. If the scale factor is 3, that means x is 33. Times 3, so times 3. Now, if you're not a scale factor person, you're just going to cross multiply and divide. We're going to multiply 11 times 18, and then we're going to multiply 6 times x. When we multiply 11 by 18, we get 198 in the calculator. Equals 6x. Now we're going to divide by 6, and we're going to get the same answer, 33. All right, moving right along over here to number 2 now. All right, so for the denominator, again, I do see a scale factor. A lot of you are going to see in a problem like this that the scale factor here is times 5. So 2 times 5 means that x will equal 10. Now again, some of you hate that scale factor idea, so let's talk about the second method real quick, cross multiplying and dividing. When I multiply 2 times 45, I get 90. And there, when I cross multiply 9 times x, I get 9x. So when I divide by the 9, we're going to get 10. Same answer. Okay? All right, so for number 3, boom, I see a times 5. Scale factor is 5. So 4 times 5, x is going to equal 20. And for the last one, I see a scale factor. 3 times what gives us 27? 9. So 7 times 9, x would equal 63. Okay? So that takes care of page 3, where we're just reviewing how to figure out whether or not two sets of fractions here are proportional. And then we reviewed here how to actually find the missing value. What you're going to do now is you're going to turn over to page 5. Okay, we're going to take a look now at page 5 together. Now, as you're flipping to page 5, if for whatever reason your page 4 is incomplete, here's page 4. We did this in class. And I think my third period, actually, you guys might not have seen this in class yesterday. Let me fix that. If my third period's watching this, if this is not done, go ahead and pause right now for practice and just practice cross multiplying and dividing. And make sure you get these answers before you move on, okay? Now we can be on page 5. And on page 5, at the top here, we have, again, the definition of a ratio. A ratio is simply comparing two different quantities. Quantity is a fancy word. You can just think of it as two different amounts or two different things. So here we've got some examples of some ratios. We've got blondes to brunettes. You can compare how much something is going to cost per pound. You can compare the number of wins to losses for a team. You can compare how many miles per gallon your car gets. In our school, we do a lot of things where we compare the number of 7th graders to the number of 8th graders. So what we're doing with these ratios is we're setting up proportions to either make a prediction or convert some stuff. Now, when we talk about conversions, a popular thing is money. We might convert the US dollar to pesos. Or if you're going to somewhere in China, you might convert the US dollar to the number of yen. There's different currencies around the world, and we are going to be converting different currencies. All right, so now what we've got is steps to setting up a proportion. First, we're going to start with what we know. One of the things you're going to see in the word problems is I'm going to ask you, so folks, what are we comparing here? Once you know what you're comparing, you're going to write that ratio with words. I don't know if all of this is going to make sense until we've seen an example. So let's go ahead now and just look at this first example together. We're at the bottom of page 5. All right, and Papa Joe's Pizza. Notice it can't be Papa John's because copyright, am I right? All right, so we're at Papa Joe's. Papa Joe's Pizza claims that 2 of their cheese pizzas will feed 7 people. If there are 21 people at a party, how many pizzas are going to need to be ordered to feed all of the guests? So here's what I mean by start with what we know. What we know is that 2 cheese pizzas are going to feed 7 people, okay? So that's one thing that we know. Now let me ask you, what are we comparing? We're comparing the number of pizzas to how many people are going to get fed. And we were given that 2 pizzas will feed 7 people. We can use that to predict how many people out of 21, or excuse me, how many pizzas we're going to need to feed 21 people. All right, so 2 will feed 7. How many will feed 21 people? Once we set that proportion up, method 1, my scale factor people, you're going to very easily see that 7 times 3 is 21. Now in blue, what I have over here is my method 2, cross multiply and divide. Over here in blue, you can see that I cross multiply 2 and 21. That's where I get the 42. And 7 times x is 7x. When I divide 42 by 7, I'll still get 6 pizzas. So let's go back up here then and talk about our steps. When you ask what we're comparing, you're going to write that down with words. Kind of like down below, we compared the number of pizzas to the number of people that got fed. We write that in words so that now we know anything with pizza is in the numerator and anything with people is in the denominator. Our unknown for this question down here with pizza was how many pizzas we would need. Pizzas is in the numerator. Our unknown was also in the numerator. Okay? The next thing we're going to do is write what we know from the problem as a ratio with numerical values. That's the 2 over the 7. So ask yourself first over here what we're comparing. Then right here, write down what you know. Then we're going to set it equal to, right here, we're going to set it equal to what we're trying to predict. Now this is getting a little messy, so let me erase. Step 1, ask yourself, what are we comparing? We're comparing pizza to people. We're going to write it with words. The next thing we're going to do is write what we know with numerical values. We know that 2 pizzas will feed 7 people. Now the third thing we're going to do is set it equal to what we are trying to predict. Our unknown is pizza. There's the unknown. And we know that we're expecting 21 guests. So this is now the proportion. And at this point, it's up to you if you want to use method 1 or method 2 to get an answer of 6 pizzas. That right here is the or. And then you're just going to label your answer with the correct units. So there's pizzas, and we're ready to move on. If you need to pause the video to take notes at any point, team, you can go ahead and do that. If you're good to go with page 5, we're moving right along to page 6. Now, we can make predictions with the proportions. That's pretty much the main thing we've been doing and using probability to do so. What I'm going to ask you to take a look at now is this next problem, number 2. If Tim received the model for his birthday, and the scale of the model used is that 4 inches represents 18 feet, we can use that to figure out the actual wingspan of the jet in feet if we know the length of the model in inches. We are not predicting anything in this situation, folks. At this point, we are straight up now converting inches to feet. And there we have it written with words. The next thing we're going to do is start with what we've been given then. We've been given that 4 inches represents 18 feet. And we can set that equal to, all right, let's see. The model is 22 inches. Inches are in the numerator, so we're going to put a 22 here. We do not know the actual wingspan length in feet, and feet is down here. So this time our unknown is in the denominator. Now again, you can cross multiply and divide. I personally do not see a scale factor. I don't see a scale factor. So in this situation, we're definitely going to cross multiply and divide. When I show my work for that, we're going to cross multiply 18 and 22. When we cross multiply 18 and 22, we get 396. Then we're going to multiply 4 times x. So we'll divide both sides by 4. And we're going to get 99. Now 99 what? We have to label it. All right? This unknown was feet. Now let's check to make sure our answer makes sense. 22 inches is in fact less than the 99 feet it represents in real life. All right, I want you to pause the video, and I actually want you to read number 3 on your own. And then once you've read it, you can hit play. So since you've read number 3 now, let's take a look together. At the beginning of a basketball season, the Warriors won 11 games and lost 7. If this rate continues, how many games will they win in a normal 80-game season? All right, we are going to be predicting. We're not converting any units of measurement. We're going to predict the number of games won out of 80. So first, I want to point out what we've been given is the ratio of games won to games lost. And the ratio of games won is 11 to 7 losses. how many games has this team played total so far? 11 plus 7 is 18. Now, why do we care about 18 total games? Because we want to know how many we can expect to win, and I should say win, not won. We want to predict how many wins out of 80 total games. So we're going to go back to the idea that they won 11, but now we're going to see it's out of 18. 11 wins out of 18 games so far means we can use that to predict how many wins out of 80 total games. So there are going to be times when you have to add, that's what that is, an add. You might need to add those numbers together to get the total. So now over here though, I don't see a scale factor, so I'm pretty much just going to cross multiply and divide. 11 times 80, please do the math with me in your calculator, is 880. And then we're going to set that equal to 18x. So now when I divide by 18, we get a 48.8 repeating. Now, since we're talking about the number of games, we're going to round that up and say about 49 games. We will expect to win about 49 of our games. Okay? All right, once again, feel free to pause at any point. You can pause and take a break whenever you need to, but now I'm ready to keep going. For number 4, this is a question talking about waiting in line. Think about the number of times that you've ever been stuck in line. You might sit there and kind of say, all right, I'm going to start timing to see how long it's been. And like if 2 minutes have gone by and only one person has gone in, that's actually moving pretty quickly. But if like 10 minutes have gone by and only one person gets to go, you know that line's moving really, really, really slowly. So I think even in lunch, in the lunch line, this happens to a lot of you. When you're standing there in line, you kind of start to consider how much time is going by and how many more people are left. And you kind of predict how much time it's going to take until you get up to the front of the lunch line. So here at King's Dominion, the waiting time for a roller coaster is 18 minutes if 120 people are in line. At this rate, how long is the waiting time going to be if 280 people are in line? So are we predicting or converting? We're still predicting here. Converting pretty much only goes with units of measurement or like currencies around the world. So okay, we're predicting. What are we comparing here? We're comparing the number of minutes that have gone by to the number of people that are in line. All right, cool. So minutes in the numerator, people in the denominator. We know that 18 minutes is how long the wait will be when there are 120 people in line. At this rate, we want to know how much time it's going to take, minutes is in the numerator, when there are 280 people down here. All right? So it's up to you. Again, scale factor or cross multiply. But at this point, I think what I'm going to do is pretty much just cross multiply just to save some time. And we'll cross multiply for the rest of them. Please do the math with me. 280 times 18 in your calculator is 5040. And we're going to now divide that by 120. All right, you divide that in your calculators. What do you get? 42. So what we're asking then is how long would the wait be if there's 280 people in line? So it looks like it's going to be a 42-minute wait. 42 minutes. Okay. All right. So now we're on the last problem of this page. A recipe for chocolate chip cookies calls for 3/4 cups of brown sugar for every 3.5 cups of flour. If 2 1/4 cups of brown sugar are used, how much flour are we going to be needing? So if the recipe calls for 3/4 cups of brown sugar, y'all, and we're going to use 2 1/4 cup, obviously we're making more cookies than the recipe calls for. A lot of times when you see a recipe, you might need to make more or less than what the recipe will actually make. So in this situation, clearly they're trying to make cookies for more people than what the recipe calls for. Now this fraction, and this fraction, and this fraction, that's going to freak y'all out. So we're going to make them decimals. 3/4 is a 0.75. 3.5 is a 3.5. And 2 1/4 is a 2.25. So what we're doing here is we are predicting how much flour we're going to need. So we're comparing the amount of brown sugar to the amount of flour. We've been given that 3/4 cups of flour, 3/4 cups of brown sugar in the numerator is used for every 3.5 cups of flour in the denominator. So if 2 1/4 cups of brown sugar are used, and brown sugar is in the numerator, so we're going to put the 2 1/4 in the numerator, we can use that to figure out our unknown, how many cups of flour in the denominator. All right, so now in red we finally have our proportion, and in green let's cross multiply and divide. So take your calculators, you're going to multiply that 3.5 times the 2.25 and get 7.875, and now we're going to be dividing both sides by 0.75. So in your calculators, divide by 0.75, please. Now, since the problem started out with fractions, I'm going to suggest that at this point we rewrite our answer with a fraction and say 10.5 cups of what? What was our unknown? It was down here, flour. Cups of flour. Okay? So once you have that taken care of, we're moving right along. And now we're basically on the last page of your packet, pages 7 and 8. Let's start with page 7. TV station XYZ is using a new strategy by airing only sitcoms and reality shows, okay? So, like, what are some sitcoms? What are popular sitcoms that are out there? Think Netflix if you need to. But you know, Full House, that's a sitcom. Friends is a sitcom. Modern Family is a sitcom. Now, what are some examples of reality shows? All right, so like Keeping Up with the Kardashians, which womp womp. What are some other reality shows out there? Big Brother, Survivor, those are the reality shows. Shark Tank is a popular reality show. So we've got this new radio station, and what they're going to be doing is they're only going to be airing sitcoms and reality shows. Popularity polls indicate that the ratio of sitcom to reality should be 2 to 3. All right? Now, first I want you to ask yourself, how many total shows then is the network airing if they're going to have 2 sitcoms for every 3 reality shows? All right? Once again, we do need to add 2 plus 3 to get 5 total shows. All right? What we're going to do now is predict if there are 20 shows total in the lineup, how many are going to be reality? All right? So we know here that 3 out of 5, 3 were reality out of the total. So we can use that to predict how many reality shows there would be if there's 20 shows in the lineup. This one I do see a nice scale factor, times 4 and times 4. So here we're going to get 12. 12 reality shows. Now the problem does not ask us this, but I do kind of want to clarify. If there's 20 total shows in this lineup, and we just said that 12 of them would be reality, that means that if 12 are reality, the other 8 would be sitcom. These would be sitcom, and these are reality. Now, the way we had originally set it up was sitcom over reality. So I'm just going to flip-flop these. So sitcom will be over reality. And what we're going to do is check to see, are we right? is this proportional to this? Yes. 24 and 24. So we know our answer is correct. 12 reality shows is correct. For number 7, Karen is planning a trip to Europe. She needs to exchange her US dollars to euros. The exchange rate is 1 US dollar represents 0.91 euros. How many euros will she get if she's going to exchange 2,500 US dollars? All right. So when you're traveling abroad, oftentimes you do need to convert your money. And it looks like here Karen has set aside $2,500 to spend on her trip. So what we've been given here, though, is the $1 converts to 0.91 euros. So we're comparing the US dollar to the euro. All right, and we can use that then to say, well, 2,500 US dollars will be how many euros? When we cross multiply and divide, we'll be able to get our answer. So we're going to multiply now 2,500 times 0.91 in our calculator. We get 2,275. Now we're going to divide that by the 1x, which is straight up 2,275. All right? Now I just labeled that with money, but that's actually not a US dollar amount. This is going to be answered with euro. I actually don't know how they label euros. I don't think it's with the dollar sign like we have. So what we're saying is, in America, she would spend 2,500. Sorry about the bell. In America, she would spend 2,500. But in Europe, no matter where she is at, that would be the same as 2,275. One thing we can notice here is that a euro, or $1 I should say, doesn't even get you a full euro. So we're going to end up with less here in euros than we started out with in US dollars. Right? I think a lot of you have seen videos of people kind of bouncing on the moon when they walk around. So like if this is the surface and you've got a little guy on the moon, they kind of like bounce around. And it's because of the difference in gravity. The moon doesn't have as much of a gravitational pull as Earth does. So for every 1 pound you weigh on the moon, you weigh 6 pounds on Earth. So what are we comparing here? Our moon weight to our Earth weight. And we were just given that for every 1 pound on the moon, it's 6 pounds on Earth. Now that should make sense. Think about it. On Earth, if you're 6 pounds, that's heavier. On the moon, it's only going to feel like 1 pound, which means you're going to kind of float around and bounce around a little bit. Okay? So what we're going to do now is we are going to predict what our Earth weight would be. Now our Earth weight's down here in the denominator, if we have a moon weight of 15 pounds. All right? So same idea. Cross, multiply, and divide. 15 times 6 is 90. And when we divide it by 1, we're actually still at 90. So we get 90 pounds. Now 90 pounds where? This would be on Earth. So if you weigh 90 pounds on Earth, you're going to be bouncing around on the moon because it's only going to feel like you weigh 15 pounds there. All right, and we are moving right along now. We are on page 8. You guys are doing great. We're almost done. I know that right now the video is already nearly 40 minutes. Hopefully you've paused along the way. 40 minutes is a really, really, really long video. But we're almost done here. We've got a few more questions, and then the sub is going to actually pass out a practice work. So for number 10 then, the liquid outer core of Earth is 2,300 kilometers thick. What that means is, like a lot of times with a sphere, when you kind of draw a model of Earth, what they're saying then in this model, it's going to have a thickness, like the liquid outer core, which is really hard for me to draw here, but it's just saying this kind of whole outer part is going to have a thickness of 2,300 kilometers. What I want you to think of is think of a basketball. Imagine that I just drew a basketball on the board, and imagine that we're talking about how thick the outside kind of orange part is compared to the inside part of the air. Now, obviously on a basketball, the outside orangey part is very, very thin compared to the amount of space inside filled with air. So our Earth has several different layers. We are on the crust. We live on the Earth's outer layer on the crust. And as we go underground, there's different layers to our planet. So what this is saying is that the liquid outer core is 2,300 kilometers thick. And there's a scale model that we're seeing of the Earth that uses the scale 1 inch for every 500 kilometers. All right? So we're converting inches to kilometers, and we've been given that one of these represents 500 of these. So how many inches in our model represents the 2,300 kilometers of that layer in real life? Same idea here. We're going to cross multiply and divide. So in your calculators, take that 2,300, because 1 times 2,300 is just 2,300. And now we're going to take the 2,300 and divide it by 500. And there is the 4.6, x is unknown numerator, inches. So that one would be answer choice B. All right, you guys are doing great. Hang tight. Only 4 more problems. Yay. All right, number 11, really easy question. The ratio of boys to girls, so we're comparing boys to girls, in a math class is 4 to 5. Boom. So 4 to 5. There are 20 girls in the class. So how many are boys? Notice we don't need to worry about the total number of students here. The ratio of boys to girls is 4 to 5. And we know there's 20 girls in the class. So we can cross multiply and divide. Or a lot of you are going to catch that scale factor is 4. So 4 times 4 is 16 boys. All right. Next, Luigi. He went to Mexico. He exchanged $750 for 2,000 Mexican pesos. Now the exchange rate is $1 US for 3 pesos. So once again, we're comparing the US dollar to pesos. And we know that $1 US represents 3. Now what we've been given this time is that he exchanged $750 US. And what they did was they gave him 2,000 pesos. What we want to know is, did he receive the correct amount? So now I want you to think back to the very first thing we did today. Is this a true statement? Is 1/3 proportional? 750 over 2,000. Now think one thing that everybody would agree with is 1 divided by 3. You guys know 1 divided by 3 is 0.3 repeated. Yay. So in your calculators, let's take 750 and divide it by 2,000. We get 0.375. So 0.3 repeating is not the same as 0.375. So no, Luigi did not get the correct amount. And folks, this is the kind of math that you need to be able to do, because when you go to the airport and you hand over your US money, you're just going to trust that that teller right then and there is actually giving you the correct amount of pesos or yen or euros or pounds if you were going to London. So if you don't know how to check their conversion, you might not actually be getting the right amount of money. So we know, no, he did not get the right amount. Now another way we can prove that real quick, just want to make sure we're okay with this. If we cross multiply 750 times 3, 750 times 3 is 2,250. When I multiply 1 times 2,000, it's 2,000. So once again, they're not the same. So let's figure out how much money, let's figure out how much money he should have gotten. If he was going to trade in 750 US dollars, let's figure out how many pesos he should have gotten. Let's cross multiply. He should have gotten 2,250. He only got 2,000, so they did not give him enough. He did not get enough pesos. All right, real quick before we move on. Try not to read that. If you had to guess, what is the strongest animal in the animal kingdom? Pause the video and take some time to just think real quick what the strongest animal would be, and then just write it down right here real quick. Just write it down. So a lot of people are going to say things like an elephant. Because of its size, a whale is going to be another popular answer. Other students think of fierceness and its ability to hunt for strength. So some of you might have said something like a tiger or a lion. All right? Some of you might have even said something like the humans, because we have machines and different things and we can be stronger than all the other animals using our brain power. Well, fun fact, a dung beetle is actually the strongest animal in the world. Now we got to be careful because obviously we, like you and me, we're all stronger than a little beetle. Duh. Like we can bench press, and a beetle, it cannot bench press. But relative and compared to its body weight, they can pull 1,141 times their own body weight. Okay? So let's figure out, if a person weighed 132 pounds and they were as strong as a dung beetle, let's figure out how much weight they could lift. All right? So once again, we know that a dung beetle, its weight, for every one of whatever it weighs, it can pull 1,141 times its own body weight. So this is how much it can pull. So a human who weighs 132 pounds, let's figure out how much they could pull or bench press or lift if they were as strong as this dung beetle. So now we're going to cross multiply 1,141 in your calculators times 132, and then we're going to divide by 1. So our answer here is 150,612 pounds. Now I want you to think about the fact that Miss Hoffman weighs about 150 pounds. I'm not going to lie to you. I'll throw that out there. I weigh about 150 pounds. Now some of you couldn't even bench press me, meaning you couldn't even lift me up. Now what we're saying here is if you were as strong as the dung beetle, you could lift 150,000 pounds, which is unbelievable. What I'm going to do now is I'm going to open up Google and I'm going to Google how much a semi-truck weighs. Those are the things on the highway, those big trucks. How much does a semi-truck weigh? Let's see what we get, 80,000 pounds, okay? So then, what we're saying then, if a person can be as strong as a dung beetle, I'm going to take that answer we just got, which was 150,612. I'm going to figure out how many trucks that would be. That'd be like you being able to lift up on your own or pull behind your back almost 2 semi-trucks from the highway. That is incredibly strong. All right. So you have made it through the notes packet. Good job. It's been about 50 minutes. So I know that was a long video. What you're going to do now that you're done with the video is you're going to go see the sub, and she's going to give you a copy of a worksheet to practice. And tonight for homework, you guys are going to have an 8-question Google form, and you'll submit that for grading. Now the puzzle sheet that you're going to get from the sub, it is a puzzle sheet so that you can verify that you're right or wrong along the way by matching up and completing the puzzle. You're going to keep the puzzle sheet, and I'm going to be collecting it from you on Friday when I am back. If this is my 6th period watching, I am going to be giving you guys this worksheet in class tomorrow since our block day gets split up. So if you're in my 6th period class, you're actually not going to get the worksheets today. You guys are going to get a head start on the Google form right now. You have 8 questions for your Google form homework. All right, goodbye.